Okay, so here are three additional problems using implicit differentiation that I've come up with. So they're reasonably complicated, but I think they're good. Okay, so we have this equation which you can't explicitly solve for y. And if we plot that thing out, so let me get a copy of this so I don't have to close anything. Okay. So I'm going to go to this graphing program I have, and I'm going to plot it. So we go to equation, implicit, and we enter the equation, which is x squared times y cubed plus x times y squared plus 4 times x plus y squared equals 3. If we plot that, it looks like that function right there. And what we're going to do is we're going to find the equation for the derivative, and then we're going to find the equation for the tangent line at -1. So here's x equals -1. If you find the y value, it turns out it's 1.91. So the slope of the tangent line should be about this, and the equation should put me right through there. Okay, and it does because I've already worked out the problem. Okay, so let's start. Let's write out the equation here. So the whole idea is you're going to use implicit differentiation where appropriate. And remember, if you have a product, you take the derivative of the first term in the product times the second, plus the first term times the derivative of the second. So let's do these. So we're going to have the derivative of the first term, which is just 2x. Now, and then we multiply by the second term. Okay, the second part of the product. We take the first term and multiply by the derivative of the second, which is 3y squared. But we add this y prime because we're taking the derivative with respect to x, and that's how it works. Okay, next one. Derivative of x is 1. Multiplied by the second. Derivative of the first times the second. Then we have the first times the derivative of the second, which is 2y, but we add y prime. Then we have the derivative of 4x is 4. The derivative of y squared is 2y y prime. And the derivative of 3 is 0. Now, what we want to do is get all the terms involving y prime to the left-hand side and the other stuff to the right-hand side. So this is going to the right-hand side. It's going to the right-hand side. That's going to the right-hand side. This one stays on the left-hand side. This one stays, and this one stays. Okay, now I'm going to rearrange these as I do them. So I'm going to put the constant first, 3, then the x, then the y, and then the y prime. So I've got 3x squared, y prime. Okay, the next one here is going to be plus 2xy, y prime. And the last one is this green one there, plus 2y, y prime. And then to the right-hand side, we have 2xy cubed, that's this one here, plus y squared, and those become negative, so let me put the negatives in front. Forgot to do that. So I'm separating them, but I'm putting them on the right-hand side, so that's negative. This becomes negative when it goes to the right-hand side. This will be negative y squared and minus 4. Now you can factor out the y prime. So you get 3x squared y squared plus 2xy plus 2y. So those are each one of those factoring at y prime. I'm going to factor out a negative sign here, so I'll get negative the quantity 2x y cubed minus y squared plus y squared plus 4, because I'm factoring out the negative out of every one of them. And I get, now I divide both sides by what's in the parentheses, and I'll get negative the quantity 2x y cubed plus y squared plus 4, all divided by 3x squared y squared plus 2xy plus 2y. Okay, so that is the answer. I'm just double checking here that I did this right when I did it again. So bear with me here while I just double check everything. Okay, so that's correct. So that's the derivative. Now, what I'm going to do next is I'm going to evaluate this derivative at -1 comma -1.9. That's the solution. So find the value of the slope. So you have -2 times x, which is -1, times 1.91 cubed plus 1.91 squared plus 4, close parenthesis, all divided by 3 times -1 squared times 1.91 squared plus 2 times -1 times 1.91 plus 2 times 1.91, close parenthesis. Okay, now I'm going to let you multiply that out, but what you'll get, if you do that, you get y prime is equal to 0.575. So that's the slope. That's the slope of the tangent line at this point. Then what you can do is you can take that point. So the point was -1 comma 1.91, and the slope m is equal to 0.575. Put that into point slope form of a linear equation. So you get that. And if you distribute that slope to both terms, you get that plus, because this is minus times minus, so it's, and then you add 1.91 to both sides. And this is the equation for the tangent line to that relation. Okay, so there's the equation for the tangent line. And if we go to our graph and we add another equation, in this case it's an explicit equation because it's just a line. And so you have 0.575 times x plus 2.485. And you say, okay, and there you go. You see right there. There's the tangent line to the curve at x equals -1, y equals 1.91. Amazing, isn't it? Okay, next one. Get a little more complicated here, but it's basically the same procedure. Let's go ahead and plot that. Just see what it looks like. Just trying to find the calculations for that particular problem. Ah, there it is. Okay, so let me close that. Okay, so this is an implicit equation. And the equation is x squared times y cubed plus y times the sine of x plus 3 equals y cubed. Okay, so that's what it looks like, at least within the range of numbers we're doing. And if you solve for the equation at x equals 2, you can see it's negative 0.87, which is on your paper. And so the tangent line should be something like that. Okay, so let's do the implicit differentiation here. So we've got this extra bit with the trig function in. Okay, so again, this is a product. So we take the derivative of the first term times the second plus the first term times the derivative of the second. Again, when we do the derivative of the expression involving y, we have to include this y prime. Okay, here we have the derivative of the first, which is just y prime, times the second. And then we have the first term times the derivative of the second, which is the cosine of x. The derivative of 3 is 0, and the derivative of y cubed is 3y squared y prime, which is what we had over here. Okay, so now we're going to take the terms that are with y prime, which is this one, and this one. Those have to go on the left-hand side, and the right-hand side stuff is out. Okay, so we have this first one. I'm going to go ahead and order it. 3x squared y prime. I'm going to go ahead and move the sign in front. Always put the derivative last. Sine x y prime. And then we bring this to the left-hand side. It's minus 3 y squared y prime. And then these two go to the other side. So you got negative y cosine of x minus 2x, oops, wrong color, minus 2xy cubed. Factor out y prime, so you got 3x squared y squared plus the sine of x minus 3 y squared is equal to negative y cosine x minus 2xy cubed. And if we divide both sides by the term in the parentheses, we'll get negative y cosine x minus 2xy cubed, all divided by 3x squared y squared plus the sine of x minus 3y squared. And I'm going to clean this up. So if we put this first, what we'll do is multiply everything by -1. So we'll get y cosine x plus 2xy cubed. And then we'll put the positive. This negative term becomes positive. Put that first. Minus 3x squared y squared minus the sine of x. So that just means we got plus signs at the beginning. Okay, so now we evaluate the derivative at the point 2, negative 0.87. So let's just put that in there, show you how it works. So you've got y, which is negative 0.87 times the cosine of 2 radians plus 2 times x, which is 2, times y, negative 0.87 cubed, all divided by 3 times y squared minus 3 times 2 squared times negative 0.87 squared minus the sine of 2 radians. Okay, so let me just double check this again. Okay, that's right. Okay, and if you plug the numbers in there, you get 0.298. I'm going to pause for just a second to double check that number because I see a slight error. Okay, so actually it's 0.294. That's pretty close. That's why I didn't really notice it, because it was close to the right answer, but I just noticed one number I put in wrong when I did it initially. Okay, so now what we have is we have the point, which is 2 comma negative 0.87, and the slope, which is 0.294. So we plug that into our slope, point slope form of the linear equation. So we get that. Y minus y1 is equal to m times x minus x1. So we get y plus 0.87 is equal to 2.294x minus, if you double that, you get 0.588. And then we're going to subtract 0.87 from both sides. So you get the equation, slope-intercept form. So 0.588 minus 0.87. Something's wrong there. Oh yeah, negative 0.588 minus 0.87 is negative 1.458. So that's the equation. So let's go to the plot here and just put another function, explicit line, which is, just forgotten it already, 0.294 times x minus 1.458. And we graph that. Hopefully that's right. Yeah, there we go. So you can see at x equals 2, we have y equals negative 0.87, and you can see the tangent line is tangent to the curve. Okay. And then the final problem is this one. So let's go ahead and plot that. This one's a little more complicated. It's the same basic procedure. Okay, so we're going to implicit. Okay, good. So we have x times the sine of y plus y times the cosine of y plus x squared equals y. And there it is, but it doesn't look exactly like what I had last time. So let me see if I've made a mistake or not. It's pretty close, but well, it looks right. I want to pause again. Okay, so I guess it is right because I just checked out my answer. Okay, so that's the function. So now we're going to take the derivative. Find y prime. If you solve it, 2 and 2.65, let's look at that. So here's x equals 2. If you go up here, it's about right there, and you can see it's a little more than 2.5. Okay, so here's the original equation. The difference here is we've got the cosine and the sine of y. So that's going to be a little different. Okay, first product. First derivative of the first term. So that's derivative of x is 1 times the second, plus the first term times the derivative of the second. Now this is where people make the mistake, is they forget that they still have to multiply by y prime. So the derivative of the sine of y is cosine of y prime. Okay, the next one, the derivative of the first is y prime, and then you multiply to the second term, plus the first term times the derivative of the second. Well, the derivative of the cosine is negative the sine, so you get negative the sine of y, but you have to multiply by y prime. So here, the derivative of the sine of y is cosine of y prime. The derivative of the cosine is negative the sine of y prime. Then we go to the next one, derivative of x squared is 2x, and the derivative of y is y prime. Okay, so let's stuff on the left-hand side, that one, that one, that one, and that one. And the right-hand side, these two. So we can leave 3 of these on the left-hand side. And so the first term is x cosine of y prime. And then we have cosine of y prime. And thirdly, we have negative y sine of y prime. Negative y sine of y prime. And then we're going to bring that to the left-hand side, so that becomes negative y prime. And on the right-hand side, we're going to have negative sine of y, which is this term, and minus 2x, that term. Now you factor out y prime. So you get y prime cosine of x cosine of y. First term, you get cosine of y. Here, you get minus y sine of y, 1. And that equals negative the sine of y minus 2x. Finally, if you solve for y prime, you're going to get negative sine of y minus 2x divided by x cosine y plus cosine y minus y sine y minus 1. And if you multiply the numerator and the denominator by negative 1, you'll get the sine of y plus 2x divided by y sine y plus 1 minus x cosine y minus cosine. Y. So these become negative, those become positive, those become positive. So let me just double check my answer here. Continue on. Okay, so that's good. Now what you're going to do is you're going to evaluate the derivative at the point. And the point is 2, 2.65. So y prime is going to be the sine of 2.65 radians plus 2 times 2 divided by 2.65 times the sine of 2.65 plus 1 minus 2 times the cosine of 2.65 minus the cosine of 2.65. Okay, I'm double checking here. 2 cosine of that, 2, yep. Okay, and when you do the calculation, you get 0.915. So that's the slope of the tangent line at x equals 2, y equals 2.65. Again, you're going to now use the point slope form of the linear equation. So you have y minus y1 is equal to m times x minus x1. And if you solve that, you're going to get 0.915x plus 0.82. So multiply negative 2 times 0.915, add 2.65 to it, you get that. And now we'll plot that line. So we're going to do an explicit equation. 0.915 times x plus 0.82. And okay, and there you go. So at x equals 2, y equals 2.65. This is the tangent line.